that. It's like codes. It's like something like
I have actually conceptualized this while I'm typing it. So update, I have start by creating a recursive function.
Yung bilang ng imposter eh.
Okay, go lang.
Oh shit!
Hi, Cristel ba?
Hirap naman yun.
Uy, nag-double kill sila. 7.
So we're back, guys. 77 is 2.2 times 77, 140. And today we are going to have our next episode of Programming with Me, which is episode 3. And now we are going to tackle about recursions and functions. And so after that, after you see me study, we are going to answer this module's exercise. And so I guess that's all you need to know for now. And yeah, back to the time lapse, guys.
What we do here is go back.
Okay. So I guess that will be all for our learning lesson. We took about 30 minutes or so in studying functions and recursions. And to be honest, I'm not sure of what to do yet. It's the first time I have heard about recursions, that I have tackled functions in Python already. And so for now we are going to know what do we need to do first. And for this we have our module to exercise is prime numbers. Prime numbers. Create a program that asks for an integer n and list all prime numbers from 1 to n. Start by creating a recursive function that determines whether an integer is prime or not. Next, ask for an integer n, then look through all the integers from 1 to n. Check each integer if it is a prime by using the function earlier, then print the integer if it is prime. So example run, we have enter a positive number, then here we are the positive numbers. So yeah, for now we are going to create a flowchart first, since it will be this problem will be easier to understand with flowcharts. So yeah, let's go. So here we have our what they call this, our flowchart that we have made. First we ask for integer n, then we use the recursive function to check all prime numbers from 1 to n, then print all the prime numbers. I have actually conceptualized this while I'm typing it. However, this is the part where I think I will have a problem with creating a recursive function. To be honest, I have already an idea how to create this using for loops. Yeah, while I was thinking in the middle of the creating my flowchart. However, the problem is, how do I make it a recursive function? Because I don't think I'll be needing a recursive one. And so for now, we're going to try to create this first. Then after I have coded and it is running properly, I will try to convert my function into a recursive function if I could. Because honestly, I'm not sure what kind of recursive function should I use. Because for now, I'm going to use my for loops for this. So we are back, guys, about 3 days from what you have seen earlier. This week was so busy, I guess, and there are plenty of things that happened that I cannot really record, but I need to record. Here we are after a few hours of thinking about it. I have found out how to make recursions. I also updated the flowchart. So yeah, okay. Here is what happened for the past 3 days. I didn't really do this for 3 days, but the day after I spent about 2 to 3 hours thinking and changing stuff. So here we have mod 2. I named them mod 2. And for this code, I did what I need to do with the problem. However, I used for loops and while loops, as you can see here. For loops, then while loops. Then after that, I manually I manually coded the for loops, and this was the code for the for loops. And we have the recursive statement. However, we still lack the base case. And for the for code, I made a function. Here is the for loops function where I coded the for loops, and here is the the while loop function, in which it checks the number if it is prime number or not. And from there on, we started having base case, I guess, but I was still unsure about this code. And so from here, from making this block of codes, we have the prime function and the prime b function. Here's the final code that I have made, where I'm pretty sure that this has the base case. We have if b equals to a plus 1, return 1, and here are the base case. Then the recursive cases, here are the recursive case. So yeah, and now we are going to, what do you call this? We are going to discuss about the comparison between the flowchart and yeah, and our, what do you call this? Oh wait, I forgot something. We still need to add enter a positive number, where we can just put it here, printf, and enter a positive number. Yeah. Then else and the prime numbers from 1 to n. No, to what do you call this? B. Yeah. B is R. Sorry about that. Is R. Is R. Then we have. So yeah. I guess this will do. Wait, let us check first. Ubuntu. Then we have CD na. Okay, it's still doing things. What is this? CD and then C programs. Now we have that. We have GCC. Mod 2, mod 2 attempt 5. That's it, I guess. Wait, what name is this? Mode 2. I misspelled that one. Mode 2. Yeah. And / mod 2. Enter a positive number, 15. The prime numbers from 1 15 are, yeah, it does work. And of course, let us put an end to this thing. Should we? Let's just do this. I guess that will do for us. Yeah, I think this will work just as well as what we need them to be. Let's try. Okay, I think I have made CC mode 2, enter a positive number, 100. Yeah, here we go. And so now, since we're sure that it is working, it's clear, then we can just exit. We are now going to discuss the comparison between the flowchart and the thing. Yeah, our code. So first of all, we ask for integer n, and the code we have here is this one. Enter a positive integer. What do you call this? Oh no, oh here. Ask for as for integer n. There. Then from there, of course, I made this so that we cannot have any number below 2, since 2 is the first, or I guess the lowest form of prime number. Yeah, I guess so. So if we have 2, then it's just going to print 2, to be honest. Here we have if A equals to 2. No. If B wait, what? If B equals to A, what's our B? Oh, it's still 2, yeah. If A equals to 2, print. Yeah. This will work for number 2 as well. For us to check, let us just have this thing going. CD, MNT, C programs. That's the name of my folder. Now we have mod 2. Since since we already have what they call this, the command enter a positive number 2, it prints. Oh yeah, it works. Anyways, so we check from 2 to 9 increasing order if there are any perfect divisor. If not, print the value. So yeah, if it's less than 2, it rejects an invalid number, it terminates the program. Else, the prime number from 1 to 0 is R. That's just used for printing, and this is the main code that we want. So here we have, we check them. We do just check them. I'm not really sure how is this working, because I think if I remove this,
What we do here is go back.
wait, just to be sure. I think we can just do this. See? Yeah. And just return 0 afterwards. We might yield the same result, I guess. So yeah. Let's compile it first. As expected, we need to put that first, and oh yeah, where are we going to return that? I guess we really need to, what they call this, to put this. Then we can just remove this, since what they call this, if it returns 1, we get to make this true. Yeah. So okay, we're back. Check from 9 to 2 increasing order if there are any perfect divisor. If not, print the value. No, n to 9. N minus 1 to 9. Yeah, I put there 9 to 2 since, what they call this? No, 10. Since I have been using 10 as the number of my checker. Yeah. So we now check from n to 2 increasing order if there are any perfect divisor. If not, print the value. So we have two functions there, both recursive function. This is the counter which checks from 2 to the maximum number, and this is the function wherein, what do you call this, wherein we check if that number is a prime number. So here we have if b is equal to a plus 1, what's the number of b? Yeah, b is the lowest number that we can get. And I change it frequently. No. The thing is that I cannot put this outside. I can also put it outside, but it will be much more efficient inside, so that we just check them again and again to the wait, I'll see if I can have an example for you of what happens here. So example, we have here we entered the number 5. Okay, how do I change? There we have the number 5. We entered the number 5. Then in our prime function here's our prime function. We ask for int a, which is a equals to 5, and b is a constant 2. So we have prime 5 2. From there, okay, we now initiate the function prime. And first of all, we have another variable which is always equal to 2. C equals to 2. B equals to 5. I think this is too big. So now it checks. Our B is number 2 and our prime is 5. Now is 2 equal to 6, which is a no. Then it goes to another wait. Oh, yeah. It checks first. It is 2 equal to 6, which is a no, so we reject that. Wait, let's make it a 3 instead. A 3. So that we don't have to take much time in evaluating our program. And so if prime BC, we have a constant of b, which is supposed to be 2. Sorry, my bad. Prime b. Now we have 2 and RC is 2. And so we go now to our, what do you call this? Prime b. Our function prime b. And I would just like to erase this. So our prime b, if a equals to 2, which this is our value of a. Here we go, int a, print 2. So from there, we print 2. Wait, how do I put this? Print 2. Okay, then after that, I'm not sure how that worked. Wait, a, b plus 1, now it becomes c. This is supposed to end the program after. Or we can just do this. Yeah, I think this will be the better thing to do. Since if a equals to 2, we just return 1, and since it's equal to 1, we just print them. Just to be sure. cd mnt mnt c c programs, and from there we have gcc compile. Yeah, mod 2. Yeah, I think this will be more efficient. We don't have to just simply print 2 then end it, I guess. since printing 2 is just the same as returning 1, and this prints out what needs to be printed. So our following is, after it returns 1, it prints number 2, then prime a b plus 1, which is, it becomes 3. So we have, from there, rb turns into number 3. And if b, which is equal to 3, is 3 equals to 4, which is no, obviously. So we check another if bc is equal to prime. This statement here checks if it's a prime function. So we have prime b is equal to 3 and 2. From there, yeah, 3 and 2. Now is is 2 divided by 3 equals to 0, which is, it is not equal to 0 to, no wait, 2 modulo 3, sorry. And so we check for the next statement. If b equals to 1, 2 plus 1 equals to 3, which is a yes, so it returns 1. Anyway, this statement here, it checks if it's the last divisor to check, since we cannot do b equals to 1, because if we make it b equals to 1, let's say we have 5 as the last number, we have 5 divided modulo 5, obviously it will return 0 because it will first check this. So if 5, since 5 is since 5 is a prime number and it returns 0, it will not print 5. Anyways, it returns 1 and it prints it, since it is equal to 1. So then we print the number 3, and now we have b equals, prime b. We add another 1. Now it checks, is 4 equal to 3 plus 1? Since it's a yes, we return the value 1. From there, here we go. We just add another line of code. We just put it in the next line and terminate program. And so that is how I did this problem. And now here we have our journal and blog for module 2. Let's see, what have I learned here? The module, the journal and blogs always ask the same thing. What have you learned and the problems you have encountered? For me, I have learned about what is a recursive case, what is a recursive function. Yeah, since I haven't stumbled upon this in I haven't stumbled upon this in Python. So having a recursive function is actually pretty new to me. And I have learned that as I have done my additional research, loops can be recursive. Yeah, loops are a kind of recursive functions. That's where I got the idea that just simply coding the while loops and the for loops manually could possibly put me out of this problem. Sadly, there is a much more deeper definition of what is a recursive function. So a recursive function needs to have a base case in which we have it terminates if it satisfies the thing. Yeah, this is the line of codes that terminates the program, the function. And we have the recursive case in which the function calls for itself. So here we have a b plus 1 it's in prime, then it calls itself prime B, it has prime B. And actually, upon my additional research, there are things and problems that can only be, what they call this, can only be coded using recursive functions. For example, the Ackermann function, if I'm right, in which I'll search it for you. Here's the Ackermann's function, in which it can, if I'm correct, it can be coded using while loops, or if it can, it will be much more efficient using recursion functions instead. Recursive functions have different use in codes. Yeah, iterative loops. It's not iterary, it's iterative, I guess. So yeah, and use this function to check from 1 to n and print all prime integers. So that is what I have learned new about this module. That recursive functions are not simply calling it itself. Instead, it also needs the base case to call it an recursion function or recursive functions. Let's see, what have we learned? There are some things that are harder using recursively. Like, for example, I knew how to do this in using for loops and while loops, while it took me some time to make recursive functions for this. What I have stumbled upon, the hardest part for me is defining, since that is where I am very weak at. I have a hard time in what do you call this? I have a hard time defining what a recursive function is. But thankfully, from my friends and after asking my prof and after searching for a while, I finally recognized the definition of a recursive function. Let's see, what more have we learned and what problems did we face in doing this? But I think that is the only problems that I have so far. I find it a bit easy on forming new functions, since I have already done that in Python. You just need to shift your language a bit, but the logic is still the same. So yeah, I guess that will be all for our, what do you call this, programming blog. And thank you for watching. Please hit the like button, the share button if it has. Click subscribe, bell notification. Probably not yet, since I still can't upload regularly, but I'll try to upload regularly. I guess that will be all, guys. So see you on the next episode of Programming with Me. We'll do module 3. I still don't know what is it about. So yeah, bye.